So the next victim on the slate is the Beckman Industrial Scopemate 2 IC and component tester that you can see before you. I picked this up on eBay a few years ago, and it's just sat and been in the long list of waiting projects that I'm trying to do restorations on and build up to complete my shop so I can get into more heavy repairs. And this is a product that is no longer made, and there are devices out there nowadays that you can buy for a few $100s that do roughly the same thing, but they don't break it down as to how simple this one is. So basically what this thing is, curve tracer inside of a switching box that allows you to check out individual circuits of different ICs or select components, individual components that you can place in this device. And let's say you can go up to a 40 pin IC and put it in one of these large modules. If you have a known good device, you put it in one side. You have a device that you suspect has some issues, you can compare the two. So what will happen is you turn this puppy on, and this, where it says transfer rate, will do, I believe it's connected to a flip-flop after reading a little bit of the manual. And it'll flip-flop between reference and test. Reference and test. So you can say, hold down pin 5. You want to look at pin 5 on the reference, and then it'll go for the device under test. And you can see them hooked up to your oscilloscope. You hook the oscilloscope up here. You put your oscilloscope in X and Y mode. And I'll show you how to do that on one of my scopes that we choose. This is powered separately. And you can see like there's a little bit of damage or something that's happened to this particular unit. So I don't even know if it works, but before I do anything, I'm going to pull it apart and I'm going to clean it. Because as you can see, it's kind of nasty looking. You can see both sides here. This thing has been obviously on a service bench. It looks like we're missing a foot here. I'll have to put some new feet on it so it's balanced. But I'm going to crack this thing open, look inside, and I guess no better time than the present. Let's do it. So I know that these come off already. One fell off on me, and you can still buy these nowadays. These are a little bit corroded, but not really rusty. All right, well, let's give this a shot. So I know that these come out and that there are sockets connected to the circuit board underneath. And what these are just little kind of rails with a, you can see that rail here move on the side, right? These are some sort of rail with a spring tension to it. And when you close it, it puts pressure down on the leads of the IC or device under test, the DUT, so you can have a solid connection. Pretty neat. So there's one of those, and I think this one should be, yep. Now, I don't know if those are serviceable or not. I see some screws on top. So maybe 1, 2, 3 screws. Maybe we can take one apart. If I'm lucky, I can get it back together. We'll see. All right, so but these are pretty dirty, so all of this is going to need cleaning. This thing must have been heavily used by somebody at some point, or it was on a service bench, but it definitely looks quite well used. So we'll see again if it works. Take this, look here. Looks like that can come off. All right, little knob. Oh, there's no nut on there. All right. Same thing with this, no nut on the potentiometer. So let's see. So that looks like it for here. And I pushed all of these switches. You can see the circuit board moving in there. When I do that, it's, oh, well, look at that. It's putting pressure on the entire circuit board and everything's moving. I don't know if you can tell. Let me zoom in on that. I'll show you. See that? I don't know if you can detect that or not. At any rate, when I'm pressing on those switches, it is pushing this circuit board up and down ever so slightly. I wonder if that's the way it was designed or if something is broken on the inside. Let's take a look here. I'm going to cheat a little bit. Oh, and those aren't long-winded anyway. Just trying to make it quick for you guys. Alright, so those three, so this side is probably held with some sort of plastic. Let's look. Alright. Oh yeah, plenty of dirt inside there to get cleaned out. So we'll have some work ahead of me. I see a broken piece of plastic here. Looks like it was a standoff for the other side. So maybe that's why we're seeing that circuit board move up and down. I'll have to come up with something to alleviate that so we don't have the pressure on there on the circuit board directly. So, and let's take this guy out. This is a neat little tool to have. Looks like that's going to be a different size. So let's try this one here. This is a little tool that I use often from Pros Kit. It's an overseas made item. They make a lot of electronic affordable stuff. I'm not sponsored by them, but it's just something that I picked up, I believe, somewhere overseas on one of my tours. It's a neat little electronic screwdriver, very light, powered with a mini USB there. Battery seems to last a long time too. So this is interesting. What is that? That's Well, I'm missing one here. This is very interesting. That looks like there's a nut on there and a screw put into that. That's definitely not factory. Wow, that's really cranked in there. And I think that was causing the circuit board actually. This is somebody's Joe Schmedley, let's fix it quick idea there. Let's see what we got. All right, so again, yeah, gonna need a little more cleaning here. That's for sure. I'm not sure what I'll clean this with. This is an older plastic. It doesn't seem to be too brittle yet, but definitely going to need some cleaning. So let's get this out of the way and let's look at the circuit board, see what I'm up against. So, wow, quite dirty. Just a film that I'm not sure where this thing was at. It's all quite very dark as well. But things are nicely labeled at least. I'm not sure if you guys can make that out or not. Let's get a flashlight here. Let's see if we can add a little more light to the circuit board. Bring it in a little bit. So you can see there's reference side, test side, that's labeled. You can see that in this shot. Let me pull that out a little bit. There we go again. So it says test side here, reference side there. BI for Beckman Industrial there. It's got a keyboard reference number here. And then these almost labeled exactly like the top here, right? So you've got the pin reference points, and you even got some resistor here. So yeah, at any rate, once I get this all cleaned up and put back together and repair those few little issues we've seen, like this, janky little screw, hopefully this circuit board works. The fuse, I can physically see the fuse. That looks good. Well, since we're here, let's do some basic troubleshooting. Let's just see. Again, this thing may work. I don't know. Let's check if that fuse is good. That can tell us a little something. All right, that's a good sign. All right, so this takes an external wall wart, and I don't have one. The specifications call for a 14 volt. All I have is 12 at the moment, so we'll see if that's good enough. So I mentioned earlier that I only had one 12 volt AC. So this particular device is looking for, this is from the operator's manual, 14 volts AC RMS, approximate, right? So I've heard of people taking 12 volts and still being able to run the circuit and get usage out of the device, but it wouldn't. So I have this, and that is 12 volts AC, 3000 milliamps. And wouldn't you know, I go to check it out, 14 and just over. Of course, that'll drop a little bit when we get a little load on it, but I mean, I'm sometimes, not all the time are linear power supplies that accurate. And in this case, I'm glad it's not, because I can get full voltage into this thing in case I need that for devices under tests. So that's pretty neat. I thought before I even went about cleaning this entire thing up that maybe I'd at least plug it up and see if it works or not. Very simple circuit. Not much can be wrong inside of it. So you're basically looking at the whole kit and caboodle right here. So let's just do a basic cap check on this. If there's going to be one part that has failed on this over the years, it's going to be this guy right here. And I believe in the circuit, it's calling for a, yeah, right here, 470 UF. It's going to be electrolytic. So you'll have the positive side, the negative side. It says Japan here, so Japan good, right? So let's see. Well, that is quite a bit above range. It's supposed to be at 470. We're showing 563. Now, doesn't mean that that isn't getting affected by something else in the circuit. Let's cross-reference this with a different device. All right, so what I'll do is I'll plug up this guy right here, and we'll check and see what the key sight says compared to the fluke. Now that's showing a little bit closer. Again, it's in circuit, so really if I'm going to test that cap, I need to pull it out of the circuit. But this can give us a more general idea. This can also give us an in-circuit ESR, just a quick general. All right, so the ESR is 0.1 ohm. So that's probably a good cap. So with that, I'm going to just think that I can power this up and hopefully have no ill responses. But if something burns, no problem. We'll fix it. That's what we do here. So let's flip this over. And I guess our only indication will be these LEDs if they're moving. Let me turn this off. Yeah. Apply power here. And then we'll turn her on. Aha, that's a good sign. So there's that flip-flop I was talking about. I don't know if you can see that well in the shot or not. Zoom in a little bit. But you can see it going back and forth. Now we can slow that down. And that looks like it's the slowest rate. 1,000, 2, 1,000, 3, 1,000. About a second a piece, somewhere in there. And what would later on the oscilloscope, we'll be able to see the device under test flip-flopping between the two, and then that will tell us if something's wrong in comparison. Now let's see if we can bring this up a little bit in rate. Go right to the maximum. Ooh, now that's really going. I don't know if I'd be able to tell which is which at that rate, but experienced eyes could. Okay, so this thing is actually working sitting at this point. As it turns out, the cleaning went quite well. Take a look at that. So I'll try to see if I can interject a photo of before and after once this is put back together. But if you look at this overall, that's a big difference compared to where it was prior. Now, some things still didn't come out. Looks like there was some glue or something spilled at some point here. And some things are just naturally yellowed throughout time, as this is from 1986. So at any rate, that turned out pretty good. And additionally, all of these turned out pretty good. So they're still wet. I just got done cleaning them. So they'll take a few days to really dry out. Now, I didn't pull these apart. I am going to pull one apart, and we'll see if it really needs to be clean. But what I did is I just took a toothbrush and I went pretty deep inside, opened and closed positions, and all of this was cleaned with, believe it or not, a product that my wife does the dishes with called Dawn Power Wash. Now, in the past, I would just use normal dish soap, and that allows you to just, scrub and clean. And you may be saying to yourself, well, how do you use dish soap and water to clean a circuit board? Water and electricity don't mix. Well, that's true. Water and electricity don't mix when something's live. And if it is a product that is something like this, where you then use the proper lubricants after for things that require lubricants, you can basically soak this in water if you needed to. But I don't go to that extent. But I just scrubbed it with a toothbrush and used that Dawn Power Wash. And it'll take a few days to dry, and it will be good as new. So that takes off all the surface corrosion. And of course, I'll look very deeply here at its cleaned process when I'm done. So why do I use this method? I can tell you, as somebody that's been on the road, literally with thousands of shows, the amounts of time that I have had gear get rained on. And then, if you're lucky, you got a day or two off where you can, maybe you got backups if you're with a big group. I know some of the groups I've been with, we have literally 2 or 3 of all the most important things. So if something does get damaged, boom, you got an instant replacement. If something gets rained on in one show, you may have the opportunity to open it up and clean it and let it dry out. Dawn Power Wash product, though, is something new, not sponsored by them, but it just really feels like it did a great job rather than just normal Dawn dish soap, which is what I would be using in a very diluted form with water and a toothbrush, and it really does a good job. So at any rate, you may even be concerning yourself saying, well, you got water down in those switches, those are FUBAR. Not true. No, most of these switches over time, I'll add just a very light amount with a hair dryer of heat, and that will move that water around a little bit. And if I'm really concerned and I think that there's standing water inside those switches, I'll open them up and I'll do a test and we'll see. But in my experience, most of these are fully sealed, and in this case these are actually not, but they are serviceable. So that's a whole other ball of wax, though, at any rate. So we'll start here. So what I do for this, because this has gold contacts on the inside, I use this product here. And again, not endorsed by these guys, but just what happens to work for me. This is the G Series Deoxit Gold G5L. Good for, gold sliders, different, sliding potentiometers, or, open contact ones like this here. So you can see the gold ones down there. You just put a little bit, you don't need a lot, and then actuate that switch back and forth a little bit, and do that a few times, get it worked in, and that's pretty much all you're going to need here. So that'll take care of that. And what I'll do here is, because let's get a little zoom in on this guy. So here we can see that there's an open back switch here. Now, when I turn the potentiometer, you can see that it opens it, and that in the opposite side is the off direction, and then closes that contact. So I'm just going to use a little bit of this cleaner on a Q-tip. Just kind of turn it inside there, because there's only that one point making contact right here. Actually, if you want to, you can see it right there, right? So just trying not to leave any threads of the Q-tip in there, and then I can actuate that a few times. And that should be all that we need. The other side, you can see here, is the actual potentiometer. So there is a variable resistor track on the inside there, and what I use for cleaning that is, this is my choice of product here. This is MG Chemicals 404 contact cleaner. It has a silicone inside that keeps the wipers on that track lubricated so they don't wear into that variable resistor track too much. You can see 2 spots here where I can actually get some liquid in. You don't need much, just a little squirt like that, I'm done. All right, let's take a look at this and see what's inside, just for fun. I'm not sure. I know that it's spring loaded. What's a long-winded screw? I'm not sure if there's going to be a bunch of springs popping out or what to expect here, so your guess is as good as mine. But these are only 2 screws that I see, and I see that it splits apart. So let's see, anything. Oh, all right. Well, it didn't pop apart on me, but it looks like, yeah, it looks like that I've one of these. Oh my, that's delicate. Okay, so looks like this is just, I don't know if you can see that there, yeah. This is just that's how it gets its tensile strength. It's just a bended piece of metal. Bended, there's a word. It's a bent piece of metal, and it's just done by spring tension. Interesting. So that's how that works. So that must go back inside here. Oh, my air conditioning turned on. Sorry about that. Oh, we're in the middle of the shot. So at any rate, so when this closes, this whole rail, whoa, all right, well, there's the whole thing. Let's see, let me turn it around. So now we can see the opposite side, all those little pins, and then that's how they're doing it. So each one of those is an individual folded piece of metal, and that's how those pins are going straight through the bottom of this puppy. Look at that. That's going to be fun getting back in there. I just pulled it out. Oh, it's going to be falling apart in my hands momentarily. And then I guess this just sits there. Imagine being the guy that has to put this together. I'm sure it's not done by hand. This is probably assembled by some sort of little rack or device. Well, or maybe I got lucky. Yeah, that's I'm missing one. I could feel that. Let's see if I can get her in there. I can sort of see it. There we go. See if I'm lucky or not. That one's just going to give me some trouble. Oh, do I got it? Yeah, I think I got it. All right, so push all those down, and that's the pins for the bottom. Okay. And then to close this guy here sits inside and literally just presses against this metal bar. Probably won't be able to do it with it open here, but let's see. Slides that whole thing sideways. Oh, yeah, not going to be able to do it. That's all right. Well, let's see if we can get it back together. Now this one here still doesn't quite look right. I'm going to have to play with that a little bit. At any rate, I guess now you know what not to do as far as taking one of these apart and putting it back together. I had mentioned earlier that I thought perhaps I had a broken standoff here, and sure enough, it is a broken standoff. However, it looks like that was done intentionally. Maybe they had a couple of models of these, or during production they realized, oops, that's where we put our circuit board. So as you can see where this would line up, if I turned that over right here, that would be directly on top of that circuit board, and at that length, you'd never close the board. So I ended up finding another appropriate screw for this in the basement, as we say, and now I'm able to just put this together. I'll put some more feet on there and we'll be back. I ended up putting some larger feet on here, just adhesive style, and so they could come off and be cleaned off if I needed to. I couldn't find another small one for the one that was missing here. Additionally, since this is a push button type of product and you're putting pressure down on this unit, I thought it might be nice if I, put some more in the middle there. I don't know if you can tell or not, but there is a slight curve to this unit. I guess over time it has warped in some way, ever so slightly. Can you see that? Just a little bit of a curve. At any rate, now with that center on there, it rocks just a little bit. So over time, I'd imagine it's going to settle back in, to a flat surface. If not, I'll remove the ones in the middle and make a compensation so it's always sitting flat and has some support when you're pressing the buttons and it's not moving and rocking all over the place like this. So as I'm reassembling this, I thought I'd show you also a quick way that you can get all of these individual connections clean. As you can see, there's all these pins here for these zip or ZIF style sockets. And these are actually, I looked them up, they're Textool by 3M. Still available, made today. Brand new, this 40 pin is about $35, from say DigiKey. And then the 20 pin is about $20. So you can still get them today. They're still made available. They come with gold pins now as well. These are not of that variety. These, again, back in 1986, that nobody was probably thinking of making gold style pins. At any rate, So what I do for something like this is I just use a regular quick drying CRC contact cleaner. And I'll just give the outside, even though I've washed them, scrubbed them with the toothbrush and whatnot, just give those a quick spray like that. Don't need much. Actuate here. And then if you have any external, you can just dry that. In a few minutes, the whole thing is dry. So the same thing here for the bottom of the socket. Just a quick spray there. And then here, just be very careful. Line it up. And you can drop it in. Pull it out. Line it up. Drop it in. Got to take your time and be very careful not to bend the pins. But you get the idea. It's hard for me to do this on camera. But, you know, at any rate, you spray it, drop it in, pull it out, 2-3 times, and that will just move the anything that's a residue on there around and clean those contacts. Good to go. Well, I was just going to start putting it back together, and we did take notice that there was a little chunk of plastic missing from here. And then I looked a little further, and guess what? Broken. So I'm going to have to go into the basement and find a jack for that. Open it back up, pull that little board, and replace that jack. So I thought I'd show how to take this small daughter board off, if that's what you want to call it, just a small circuit board here. There's a little piece of plastic here. Now sometimes throughout the years, these get brittle and they can break, so be prepared for that. I don't know that these will, but we'll take a look. So you just kind of squeeze them like this and then lift the board off around that. And then work around each side just a little bit, causing those to go through. And as you can see, starting to get the first one here. Now there's a set of pins here you have to be very careful when you lift. This may not be the tool for, I guess it was in this particular case. So we'll go around here, do the same thing. Squeezing those bad boys. Trying to get a little lift on there without forcing. And they're old and brittle, so you got to take your time. And actually I'm going to take this one, give a little bit more of a squeeze there, both sides. And there we go. Should be good to go. All right, so that's how that guy comes off. Looks good. So what's next now? Let's get this back in the shot. So now I have to replace this jack. Now, when replacing one of these, if you've never done one before, unfortunately for me, I was lucky I happen to have one in the basement, as my wife and I always say. Can always find what is necessary in the basement. These three, as you can see here, connectors are flat, right? And they go into these slots here. So a couple different methodologies. You can take solder wick and pour them on there. And believe it or not, when you're using solder wick, some people will do this, some people won't. You can add a little flux to kind of wake up. And if you're having problems, you can actually add a little bit of solder, believe it or not. Also, to get the connections to wake up a little bit more, and that's what I like to do. Add a little fresh solder, just a touch, before I start actually pulling the solder off. And it comes off real easy then. You can see how much came out there, right? So rather than fight it, maybe a little bit more messy with that flux, but I can tell you it makes a world of difference when you're trying to get these guys out. You can see how it really floods the solder braid there. And I'm almost done there. But again, you got 3 to go with, right? So that's the one side that I did. Now we'll do the other side. And one more. And we'll see if that comes off now. Almost. And you have to be careful with some of these too. If you happen to have a trace on the other side, if this happens to be a through hole via, in this case I can't tell yet because the let's see if you guys can still see that. Yeah. I can't tell yet because the jack is still on there. So I'm not sure which ones are holding on. So let's give a little heat like this, and that should be able to pop it through. Put a little forward pressure. There it is. Well, there's part of it anyway. We've got a little bit more to go. So again, I'll put a little heat and pressure. And there's that part coming out in chunks. Look how broken that was. My goodness. That thing definitely took a hit at some point. So here we do have through hole vias, but there is no trace leading on this side. This is a dual trace side board. Traces on one side, traces on the other. And in this case, let's clean this up just a hair so you can see. Kind of wipe that off there. And in fact, depending on what you're using to clean these boards off with, for me, typically I'll use lacquer thinner to get the flux off, basically. So that guy's there, and I can see that I have 3 individual traces there. None of them are disturbed. So this should be relatively easy. Yeah, that looks pretty good to me. So now we'll put this guy back in. And just voila, just like that, instant fit. Straight, looks good. So once again, good old flux. And just try to get it the areas that I need it. And that should be enough. So what's my temperature for something like this? Where am I at? Right about 725 degrees. That seems to be enough. Maybe it's a little too hot for some folks, but I like to solder fast. So what I like to do is I do one side and then let it set, and then it can flood all the way in. Now what I do is, because that iron is a little bit hot, I'll take a heat sink here and I'll just use this tweezer as a heat sink, because the other side of this is just plastic, and if you get it too hot, it will melt that plastic and you'll be ruining the jack. So because I'm right-handed, I'm going to go this direction. Boom, just like that, and just like this. And then this little tweezer here will help to sink that heat off there. That should be enough there. And then we'll do one more. Again, I'm right-handed, so I'll keep going around the circle here. Try to get a full, there we go, strength. All right, and that should do it. It should be good to go now. So what I'll do now is I'll just take a little bit of acetone you can use, lacquer thinner, and I'll just take a toothbrush, put some goggles on the spectacles, right? And clean off that flux there on both sides, and then we'll put this back together. So as I'm gonna go and put this board back on there, I did the same thing. I just spray those little these pins here that sit inside this socket here. just a little bit with contact cleaner, quick spray, and be careful, line them up. You can physically look underneath, you can kind of see there, I use a flashlight, how they're supposed to line up. So I'm going to do that on camera or not. There it is. You can kind of feel where they got to go. And once they're in, just gently drop the board down inside. And she's good to go. I figured we should probably see if the pins are all connected and working after we did the cleaning and everything is still functioning as it should. So what you'll see here is you'll see two strips that are common. Again, this is the reference side of the scope component tester. This is the test side. So that means the reference side, you would put the good known device and the suspect device would go on this side. So before you do any of that, since again I did a restoration of this, I just want to make sure that I have good contact. So let's say pin number 1 here, where I would add my common jumper to, I should get something here on pin 1. Now would I get it here? No, because this is for this side. So this is separate. Would I get it here also? I should. There it is. I'm just holding the pin wrong. But I can go through and test all of these. So there's number 2, number 3, number 4, number 5. You get the idea. So, but what's interesting about this layout is I noticed when I was cleaning it where the traces were running, and you might think this is labeled pin 1 down to pin 20. Well, I got a 20 pin socket here, so there's 5, 10, 15, 20. This direction like a normal IC. It's not the case here. For the sake of simplicity, what they've done here is since you have a 40 socket here and a 20 socket here, this being the 40, this being the 20, what they've done is they've come down 10, they've reversed it and gone back up. So if we look at pin 10 here, this is actually, let's find it. Yeah, there it is. So pin 10 there is actually on that side, and then pin 11 for here is there. 12, 13, 14, 14. You can see, right, the way that it works. So this is not getting down in there far enough for me to, I could probably use a piece of hardwire, which would be better than this for testing. But at any rate, this should be the same thing with this socket here, pin 1, pin 2, and again, this follows all the way. Now this goes down to 20, this turns back up. Conversely, if I go down to 10 here, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I have connectivity here, but if I go to 11 here, nothing. So actually 11's here, 12. And it goes back up. So this follows that same 20 pin count. Interesting, I thought. At any rate, so how can you then make sure that you have connectivity between both? So if I go pin 1 here and say pin 1 here on this side by pressing the button, right? 1, but I have nothing on anything else, right? I can check 2. 2's working. Now, same thing. I should get 2 here. Let's see. There it is. I should get 2 here. There it is. Okay, so you can see how it's laid out. And I'll spare you me going through every pin to make sure, but I'll make sure that I do that, that I have connectivity throughout. So in the future, I have peace of mind knowing that the device is working on a basic level. So that aside, if we look at what this common jumper is for, this is just to put this guy right here in, and this came with the scope. You could make one of these too if you wanted, but you put that in the common jumper, and which you have to go to the data sheet of your device. Like this is a TL074, and you would put pin 1 on pin 1, drop it inside, close this guy here, You would put your suspect device for comparison on the other side, and then look at your data sheet to find out which one is the common for the TL074. I don't know at the moment. I don't remember off the top of my head, but you would take the common and put that wherever that is here in correspondence. And then when the power turns on, it will turn on the device, and you can test and look at the device in a static way on the scope. So that's what we'll do next. Additionally, if you wanted to do an individual component test, you could put this guy, and all this is the same style of access point, and with two alligator clips. So let's say you wanted to put a diode on one side and a diode on the other to have the reference. Great. You wanted to use, say, a poly cap. You could look at a poly cap from one to the other. So you can do individual components as well. And you don't necessarily need to use these. If you know what you're doing, you could actually, let's say I wanted to do this poly cap right here. I could count out pin 1 through pin 4 and drop that there. Put my other poly cap over here, pin 1 to pin 4, and I could let the flip-flop circuit on the inside let me see both sides as it's moving. So you don't necessarily need to use these, but if you're more comfortable doing that with two-leg devices as, you know, individual components, that's one way to do that. You can also use a three-leg component transistors this direction, pin 1, 2, and 3, or you can choose whichever pins you want. As long as they're the exact same pins on the other side for comparison, you have a match and you have a testable setup. You can test them individually by the individual connections here and watch them on the scope. So that's what's coming up next. So here we have the Scopemate 2 set up, and I've adjusted the lights in the room so hopefully you can see that trace on there well enough. So basically the X mode of my analog oscilloscope here is going from BNC 50 ohm coax down to the RCA out of the Scopemate 2, and then the Y is doing the same thing. The scope is in XY mode. Now you can see that the trace on here is slightly slanted. Now I could use trace rotation on here and fix it one way, but for the opposite direction, it would then be out. So this is a characteristic of something that in the circuit itself would need to be fixed. And there's a little thing that we could add a variable resistor in there that would allow us to adjust that trace rotation. And maybe I'll do that, maybe I won't, but this is a very simple device. So how this is laid out is, if we look at these cables, these are two clips, two banana for component. Then there's a common jumper here. And depending on which chip you're putting inside here, you have to look at the data sheet to see which is the ground. Essentially what's happening is, by putting in this jumper, connecting it to whatever pin the IC is calling for, you're essentially checking the circuit, compare it, and pulling that to ground, right? So we'll start with something very simple here first. Let's say that we just start with a cap, right? So even before that, I can say that because this is pulled to ground and it's on pin 1, if I press this button here, pin 1, it should give us, yeah, so it's pulling to ground and giving us the opposite access, right? So XY. So this guy is just a capacitor, and I'm going to put it in pin 1 and pin 3 right here on the reference side. And if I press 3, because we know 1 is pulled to ground, there we get its Lissajous characteristic, and in this case that's a circle, right? So now let's say I wanted to compare that to another one. So I have an identical one here, and I'm going to put that in the test side. Again, this side being reference, this side being test. And I want to test the two of them. I could either put the switch on test, and I could look and say, oh, there's another one. It looks pretty good. But I want to see if there's change between them. Maybe I want to get them closer, discover if there's a problem. So I put this on alternate, and you can see the LEDs in its slowest setting here, switching through that flip-flop on the circuit, the flip-flop relay, reference, test, reference, test. So in this case, I'll press 3, and you can see a slight change. Now you're seeing some spikes here that the oscilloscope is picking up to the relay contacts opening and closing, so just disregard that. Now we could change this and go a little faster. If your eye can track that, But these are very similar. You can see a little change happening up here, but very similar. Now, just for the sake of demonstration, I'll take this cap out. You should be turning this off every time when you're changing components as well to avoid this unwanted spike. At any rate, so I'm going to put this cap of a different value in there, and let's compare them. So lowest setting here, I'm going to go on to 3. Now we can see that the left side, right side, left side, right side, left side, right side. They're the 2 different caps, and it's just, again, that flip-flop is just showing you which one is on and active at the time in comparison to ground, and it's running 12 volts across both of those caps to give us the pattern here. So that's the basic premise of this unit, and that's a very simplistic way to do it. Now these particular caps right here have very thin leads on them, so I can put those safely in these zip sockets here. And now what if you had a component that was very thick like this? Like, look at the hefty leads on that. And that's where these come in handy. So you can put the component, you can see the test there. So this is the left's reference, test, reference, test. You sort of have to remember that. It'd be kind of nice if I had 2 LEDs that were actually up here somewhere, because you got to kind of see that in your eye or kind of time it so you know which one is which. So let's just look at, we know that if we put another one of the same value in there, they would be very similar, but let's put something different in the opposite direction, just a different value. Now we have 2 different value diodes, or 2 different Lissajous patterns as a result, just to show for demonstration purposes. All right, so that's enough for the components, I think. So let me turn this off. Now let's look at how would you function in IC. All right, I've made a few changes to the room environment here, so hopefully they'll be good for the eye. So what I'm going to do now is I'm going to put 2 known good 555 timers in here. And these are 8-pin ICs. Put one in the reference side, one in the test side. Close the pins on them. We'll turn the unit on. And starting the flip-flop process. So let's look at, of course, pin 1 is ground, right? So if we go to pin 2, we can see that, see the very little bit of difference that's happening there, but they're very, very much the same. I'm not sure if the video can pick this up or not, but there's a slight difference happening there as it flip-flops. Let's look at pin 3. That's its characteristic for pin 3. Pin 4. Now you would think that if you went down the line by the numbering here, that pin 5 and so forth would correspond, but because we're using the smaller socket, and like I mentioned in the earlier shot, it actually goes in the shape of the IC. So in order for me to get to pin 5 here, I have to go up, and it's actually pin 37. Now you can see that there was a slight bit of, let's see if I can get it to do that again. Yeah, slight bit of difference there. I have a problem with this particular switch. You can see that as I move this around, that switch is dirty, or the contacts are not being made very well for some reason. So I'm going to have to pull that switch and repair it. But let's go on, moving 4. So here's 4, and that switch feels fine to my finger, no problems. And then this would be, so that was, let's see, 4, 5, 6, that was pin 7, and then of course pin 8. So this device is good, right? So let me turn this off now. Let's look at 2 IECs that are bad. And this is something that I discovered, and the reason that I want this unit is because a lot of chips that I use in certain projects may not be available nowadays. And in electronics, it's common to have people pull certain chips. There are guys that do this. They pull the chips from devices. The devices say obsolete now, but the chip still has value on the market, and nobody makes the chip anymore. So they'll pull the chips out, and they're just known as pulls, and then they'll sell them on, used on eBay, whatever, in different formats. And if you have need for that chip, then you can buy it. I think it's great that people do that, but sometimes you get duds, and they damage the ICs when they pull them out. Too much heat maybe, you know. So you can look at any one of these ICs, integrated circuits, and let's see, let's take an example diagram of the inside of a 555 timer, the one we looked at just a few minutes ago. And you can see that there's individual circuitry in here that we're looking to, that are giving us that Lissajous pattern. See some resistors, the flip-flop that this one has also. So if you look at the data sheet for the device on your test, it can tell you a lot. And again, this is a very simple way to test one IC versus another. This does not give you the comparison of a fine electrical understanding. There are machines out there that do that, that can look at an individual IC and they can give you readouts as to what the values should be very specifically. Again, this is just is this thing good or bad on a basic level. So not very scientific here. So now let's take a look. So pin 1, of course, is our common. Pin 2, now you can see when it goes to the reference side that my good known device looks like that, and the bad one looks like it's open. Not even a short. Let's go to pin 3. Same thing. Pin 4. Good one, bad one. Good one, bad one. Pin 5. Yep, this IC is just shot. Pin 6. Of course, there is nothing happening there. Pin 7. Now, if I want to get to pin 8, if I actually press 8, you'll see that there's nothing, but I have to go up to pin 34. You can see good device, bad device. That's the Lissajous pattern. Nothing wrong there. That's just how the circuit looks on the inside. If we wanted to look at that individually and say, we could just put it on reference, and I could toggle this to test and say, oh, that one's no good. So that's another way that you can slow this down. Let's go to, all right. So now we're on pin 9, pin 10. So you can see this IC over here is just, everything's open. It's shot. Pin 11, so forth. Yeah, so this one's done. And that's the whole purpose of this device, is I can now say, sadly, let's see, this is a 1468CN, and this particular chip is a voltage regulator kind of chip that actually is a balancer in a sense. If you can use this in a circuit where you have a positive and negative voltage, and it will track them on either side and allow you to have a little bit more accurate voltage out of a power supply. But unfortunately, this old chip, which is a pole, is gone. So I guess another way that you could try to troubleshoot this for itself is, so for instance, when I'm on this pin right here, can you see that as I am toggling this, that it's not quite stable? All right, let's compare that to another switch. We'll go one back. This is switch 12. See how clean that is and crisp? Go to 13, and there's a little, so as I move the switch even, there's a little wonkiness with the switch. So 13 is going to need to be serviced. So I can go through all of these. 14, that looks pretty good. 15, that looks pretty good. So far I know that 13 and 37 have issues, right? So you can just go through the entire unit here, check each one of these to see if there's a problem.